Hello and welcome to my YouTube channel. In this video, we are going to see how we can implement the interrupt based analog to digital conversion using Nucleo STM32F44 6RE microcontroller board. In the previous video, we discussed about the concepts related to interrupts and why interrupts are better than polling method. Let's continue with the second part. So in the last part, we have discussed that we'll be using interrupt to read the LM35 temperature sensor instead of polling method. The connection will remain same and rest of the things will remain same. Only thing is the implementation part and the coding part. So let us continue with the coding. For that, I will open the STM32 Cube IDE, go to new STM32 project, and then we will select the microcontroller board. In this series, we are using Nucleo F44 6RE microcontroller board. Therefore, we will select that and click next. Give a name to the project. So let us give a name interrupt based ADC reading and then click finish. Like usual, we get the message initialize all peripherals in their default mode, and we will say or we will select no. This will take us to the CubeMX perspective where we will do the initialization of the ADC and clocks. So let us go to pinout, clear pinout, and we get a warning pinout will be cleared. Okay, no issues. We will say yes. And then let us go to the system core, RCC, select the clocks for high speed clock and the low speed clock source, and then for debugging we can use trace asynchronous, and then we can select the ADC channel through which we want to read the temperature sensor. Like in the previous videos, we will use channel 1, and you can see here we have selected PA1, which is ADC1 input channel number 1. And then because this time we are not going to use polling, we'll be using the interrupt method. So for that you have to go to NVIC, which is nested vector interrupt controller, which manages all the interrupts related to hardware or software. So this time we are using ADC for generating the interrupt, therefore we'll be enabling the ADC interrupt. That's all, and we will generate the code. Click on the gear on top, or you may use save all option. This will generate the basic code and it will initialize all the important peripherals. Here in this case we are using the ADC, therefore ADC initialization has been conducted or completed by the CubeMX. Now let us start writing a code by which whenever there will be an interrupt generated by the ADC, microcontroller will read that value and then again it will go to the main program. So for that, let me first initialize some variables or declare and initialize some variables. Okay, so we will go to the private variable section for the users, and here we will declare some variables like ADC value, temperature, resolution of our ADC. If you recall, our ADC is 12-bit, therefore 2 to the power 12 will give us 4096, or we can say 4K. Then we can declare some other variables, float voltage, float Vref. If you can recall, the voltage reference for the STM32 F44 6RE microcontroller board is 3.3 volt. Therefore, we are using 3.3 voltage reference. And then the temperature coefficient of the LM35. If you can recall, again it is 10 millivolt per degree Celsius, which will equate to 0.01. And then lastly, we will introduce, or we will declare one more variable, ADC underscore valid. So this is all about the variable initialization and declarations. Now let us go to the second part, where we will have to initialize the ADC with interrupt. For that, we will go to the user code section begin 2, and we will initialize the ADC. Okay, this time we will be initializing or starting the ADC with interrupt. Therefore, we will be using start underscore IT. We will pass the handler and done. Now for the third part, here we will use the code which will check if the ADC value has been generated or not. So let us go for ADC underscore valid. If the ADC value or this variable is 1, then in that case we will make the ADC valid equal to 0, and then we will start the interrupt again. We pass the handler, and let us keep a small delay here, all underscore delay of 50 milliseconds. You may take any other value also. So this is the while loop, where this part of the code will keep on repeating itself. Now remember, here we are initializing the ADC with interrupt. So therefore, we will have to use the functions which are related to the interrupt. So let us go to the driver section, all driver, source. Here you can see the adc.c file is there. Double click on that. This will take us to the adc.c file, and here on the right side you can see in the outline section all the functions which are related to the ADC. So now we have to select a function which will give us the value of ADC. For that, we will use a callback which will be initialized whenever the ADC completes its conversion. For example, here you can see void all underscore ADC, and this is short form for conversion complete callback. And you can read here regular conversion complete callback in non-blocking mode. HADC pointer to a ADC handle type def structure that contains the configuration information for the specified ADC. Remember, this function is weak, therefore we may use it in our main function. So let us copy this function in our main and let us go down and use the callback in the user code section begin 4. Okay, and here we will write the code related to ADC. So if HADC is converted or it has received the value from the HADC1 handle, okay, in that case, that means the conversion has completed. So we will use ADC value, okay, and it will read the value of ADC. ADC underscore get the value from the handle HADC1. Okay. After getting the ADC value, we can convert it into equivalent voltage. For that, we can use ADC underscore value multiplied by V underscore ref. This we all did in the last part. Okay, this part of the code was covered in the last video also, so it won't be that difficult to understand. So ADC underscore resolution. Done. This will give us the equivalent voltage for the ADC value. Now let us convert to the temperature. So temperature is nothing but voltage divided by temperature coefficient. After getting the temperature value, we can make the ADC valid equal to 1. So this callback is generated by the interrupt. So whenever the ADC conversion is completed, this callback will be generated, and then these 4 lines will be executed. And after that, again the system goes to the, or the CPU will go to the while loop. Okay, where if the ADC valid is 1, then again it will make it 0 and start the ADC interrupt. And if there is any interrupt generated, then it will directly go to this callback and execute the program. Let us build the program. So there are some issues here. So V underscore ref has not been declared. Okay, let me check. I missed the equal sign. Okay, done. Now let me connect the board and open the camera. Now the board is connected, and let us debug the program. Okay. Now the program is waiting at the hall init function, Let us go to the live expression and use these three variables, ADC value, temperature and voltage, okay, to see the values of the ADC and corresponding temperature. So let me resume the program, and you can see here we are getting the value of temperature, we are getting the value of ADC and its equivalent voltage. So right now the temperature is somewhere around 28 degrees Celsius. So let me check if I can change the temperature. So I will pinch the temperature sensor and you can see the temperature rises to 31 degrees Celsius and gradually it will go to 32 degrees Celsius. Remember, this time we are not using polling, instead we are using interrupt to read the temperature sensor. So if I move my fingers away from the sensor, we can see the temperature again goes back to the room temperature, which is somewhere around 27 or 28 degrees Celsius. So in this way, we are basically keeping the microcontroller not that busy because we are using interrupt to read the temperature sensor's value. With this, I would like to end the presentation. If you have any doubt or suggestions, then please share your doubts and suggestions in the comment section. If you have not subscribed my channel, then I would request you to please subscribe my channel and press the bell icon so that you can get the notification as soon as I upload a new video. With this, thank you and have a nice day.